Hi guys, let's take a look at this question where we have a circuit diagram with EMF 12 volts with an internal resistance of 0.5. We also have a light bulb with resistance, and then we also have three other resistors, a closed switch and an ammeter. 8.1. State Ohm's law in words. Please just memorize this as is. Ohm's law is the potential difference slash voltage across a conductor is directly proportional to the current in the conductor at constant temperature. Then switch S is initially closed, right? 8.2.1. Calculate the total external resistors of the circuit. All right, so what is the external resistance? We have four different resistors here. One, these two are in parallel, but they are connected with that light switch. So that's going to be an addition there. But then the light switch is also in parallel with R3. Do you see that? So that's going to be the external resistance. Let me show you. So I'm first going to calculate this parallel. So this parallel resistance there. I'm going to use my easy formula, the product over the sum. It's going to be 10 times 10 divided by 10 plus 10. I put that into my calculator and I should be getting 5 ohms. So this is now the parallel resistors of 1 and 2. You can call it 12 if you want to. Then the light bulb resistor is also in that region. So we got to add, right? So parallel resistor 1 and 2 plus the light bulb is going to be 5 ohms plus 10 ohms. And that gives me 15 ohms. So this resistance here would then be 15 ohms. But then the light bulb resistor, right, is also in parallel with R3. So there we have another parallel, which is going to be the light bulb and resistor 3. So that is going to be, again, the product over the sum. So now the light bulb, remember, it's in connection with that. So we got to make it the whole amount that we've just calculated of 15 times resistor 3, which is 15, divided by 15 plus 15. And that will give us an R parallel total of 7.5 ohms. That is going to be our R total or external total. 8.2.3. The reading on the ammeter. So there we have the ammeter. Okay, so if we can look closely, we can use actually whatever we need to use. I'm going to use this formula because it will just be very easy. They've given me my EMF of 12. I need my current. My resistor, external resistance, I've just calculated to be 7.5. And my internal resistance was given as 0.5. I put that into my calculator. I take I over, divide, get I alone to be 15 or 1.5 amps. And then they want us to calculate the power that's dissipated by resistor R3. So we need one of these formulas to work, right? So we're probably going to use the easiest one where we just need the current and the resistance, right? So 8.2.3. I'm first going to have to find then my current that's flowing here. So I have my external resistance, right? But I don't have my external voltmeter. So I have to go, we only have the internal volt there. I need my external volt. So that's what I have to go calculate, right? Firstly, okay. So that is going to be 7.5. That is going to be the unknown. And we've just calculated the current on the ammeter to be 1.5. So external volt is going to be 11.25 volts. Now I can calculate my current running through here. So I can use the exact same formula actually to get my current. So my resistor is 15, my external volt is 11.25, and my current is the one that I'm looking for. So I do my math magic and I get my current to be 0.75 amps. So 0.75 amps. Right. But I'm still not done because they asked for the power at resistor R. So now I'm just going to show it all the way there. So now the power is then equal to current squared times resistor. I'm just using that formula. So current is going to be 0.75 squared, and the resistor is 15, and that gives me 8.44 watts. Okay, so now I'm just going to clear the screen to do the final answer. So switch S is now opened. 8.3.1. If the resistance of the light bulb remains constant, how will the brightness of the light bulb be affected? Will it increase, decrease, or remain the same? It will increase. Now we got to explain that. So how do we explain that? So the switch is now opened, right? So that means the total resistance of the circuit increases, but then the current total decreases. Okay? Bear with me. The internal volts will decrease, but the external volts will increase. Okay. And as a result, the power output will increase, which means the brightness of the bulb will also increase. Okay. And that is it, guys. See ya.